That's a very funky N. Okay. So what's the first step? You have to write the K. You have to do this. And then you have to determine how many of each element there are in this. K, there's 1. And manganese, there's 1. And oxygen, there's 3. And then you have to find their atomic mass, which potassium is 39.1 grams per mole. Manganese, it is 54.94 grams per mole. And then oxygen, it is 16 micromoles. And then you have to multiply through again. So that's going to be 39.1 grams per mole of potassium. And then for manganese, it's going to be the same thing, 54.94 grams per mole of manganese. And then for oxygen, 3 times 16 equals 64 grams per mole of oxygen. And then, if you guys remember, you have to add the 3 totals together, 39.1 plus 59.94, and then 64, and that equals 158.04. Grams per mole. Okay. And then the last step is that you have to take each of these totals and divide it by this total, the overall total. So 39.1 divided by 158.94 times 100, and that equals 24.74% of potassium in this compound. And then for manganese, it is 54.94 divided by 158.94 times 100, and that equals 34.76%. And then for oxygen, it is, I'm going to put it over here, 64 divided by 158.94 times 100 equals 40.5%. And those are the answers. You would circle or square each of these. And that's your answer. And I also have another example for the second thing that we did, which is finding the empirical formula from composition. And this problem is 40% carbon, 6.67% hydrogen, and 53.33% oxygen. So I'm going to give you guys a couple minutes to try this, and then we will go through it. So, of course, the first step is to create these into masses. So there's going to be 40 grams of carbon, 6.67 grams of hydrogen, and 53.33 grams of oxygen. And then the second step is to find the atomic masses of these. So for carbon, it is 12.01 grams per mole. For hydrogen, it is 1.01 grams per mole. And then for oxygen, it is 16, like it's always been. Like, oxygen and hydrogen are going to be ones that we use a lot, so you probably will have those memorized before you know it. And then you won't have to look for it as hard as you normally do. And then you have to do the same thing we did in the other example, which is multiply the mass times or divide it by the atomic mass by using the conversion factor. And then when you get the answer, it is 3.33 moles of carbon. And then it is 6.67 divided by 1.01 equals 6.6 moles of hydrogen, that's carbon, and then 53.33 grams divided by 16 equals 3.33 moles of oxygen. And then you have to decide which one is the smallest, and there are two of them that are the same, so you just divide these three answers by the smallest. So 3.33 for carbon divided by 3.33, and that equals 1. And then for hydrogen, 6.6 divided by 3.33 equals round 2. And again, you have to round. So if it doesn't equal 2 or whatever number exactly, you just round it. And then for oxygen, 3.33 divided by 3.33 equals 1. And then that helps us determine how many molecules there are for this. How many atoms of this molecule are in this molecule? And then you just have to write this down. So CH2O, CH2O. And that is the answer. This is not the answer, that's the answer. And so you circle this one. Okay? And then I do believe there are some work alone problems. So I will give you guys a few minutes to work alone on these problems, and then reconvene because I have the last section of notes for today. Okay, so next we are going to go over percent yield, and we are on page 15 for percent yield, and percent yield is the ratio of the actual yield, the amount of product obtained from the experimental, to the theoretical yield, which is the amount of the product predicted from calculations. So theoretical is kind of like in a perfect world, how much you should get, and then actual yield is how much you get with the experiment when you're actually doing it. And then it's expressed as a percentage, so that means you have to multiply it by 100 again. And then the formula for that is actual yield divided by the theoretical yield times 100. So the example that I gave in this one is that a chemical reaction theoretically produces 15 grams. So theoretically produces 15 grams of the molecule of the product, but the actual yield is only 12. So actual divided by theoretical times 100. So 12 divided by the 15. And that equals 8. And then you multiply that by 100, which gives you 0.8, that equals 0.8. And then you multiply that by 100, and that gives you 80% for the percent yield. And this type of problem will become more relevant in the coming units. I just wanted to introduce this to you guys so it was floating around your brain a little bit. So we have some percent yield work together problems on page 15. Remember, the formula is the actual yield divided by the theoretical yield times 100. So the work together problem I have is in a synthesis reaction, 25 grams of magnesium reacts with the excess nitrogen to produce magnesium nitride. The theoretical yield, so T, equals 40.07 grams, but the actual yield equals 36.5 grams of magnesium nitride. So you would take 36.5, divide it by the 40.7, and then that equals 0.8968, and then multiply that by 100, which you just move the decimal place 2 points over, and that gives you 89%, 89.68% for the theoretical yield, the percent yield of magnesium nitride. And then on the next page, page 17, I have another problem for us to work through. I want you guys to try this problem on your own, and then we will go through it once you're done. So pause this video if you need. Okay, so in a decomposition reaction of potassium chlorate, KClO3, 225 grams of KClO3 decomposes to produce potassium chloride, KCl, and oxygen gas, O2. The theoretical yield, which is T, of potassium chloride is 74.55 grams, and the actual yield is 70 grams. Okay, so you would divide 70 by 74.55 and get an answer which would equal to 93.90, or 0.9390, And then you would multiply that by 100, and that would equal 93% or 93.90% for the percent yield of potassium chloride. So I also included 2 work alone problems for this unit, or for this lesson, and you also have the 6 work alone problems for the other part of notes. So those are due tomorrow. If you haven't gotten the homework done from yesterday, please get that turned in and done today too. And we reviewed the formula mass, molar mass, Avogadro's number, the mole, and the empirical formula, which is all stuff that we went over either yesterday or Monday. And then the new content that we covered was the percent composition and the empirical formula that you can find from the percent composition, and then the percent yield. So please make sure you get your homework done. Have a good day, guys.